Hello, in this lecture we will find the value of x in two different methods. In the drawing we have quadrilateral SRPQ. We know that side SP equals to side SQ, and we know that this angle SRP equals to 65 degrees, and angle PRQ, this angle equals to 50 degrees, and we want to find out the value of angle X, that is actually angle PSQ. Okay, so we start with the first method. In the first method we will do a construction. Actually, we will extend QR. We will extend side QR and from point S we will draw a perpendicular to the extended QR. So this angle is a right angle, it equals to 90 degrees. We will define this point as point N, and we will also draw a perpendicular from point S to PR. Okay, so here this angle is a right angle, it equals to 90 degrees. This angle is also a right angle because S, from point S we draw a perpendicular, so this is a right angle, and we will define this point, the touching point between the perpendicular to PR, as point M. And so in the next step we will focus on the right triangle SRN, the right green triangle SRM, and on the blue triangle, blue right triangle, triangle SNR. So the blue triangle and the right triangle, both are right triangles. Before that, we extended QR with a straight line, so actually QN is one straight line, and we know that the sum of the angles on a straight line equals to 180 degrees. Therefore, at point R along the straight line QN, the sum of the angles will be equal to 180 degrees. That is to say, here 50 degrees plus 65 degrees plus the size of this angle, I will call it angle Y, plus the size of angle Y must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line is equal to 180 degrees. So okay, so we have this equality that the sum of the angles at point M equals to 180 degrees. That is to say, 50 degrees plus 65 degrees plus the size of angle Y must be equal to 180 degrees. So here we will subtract 50 degrees from this equality, and we will get that 65 degrees plus y equals to 130 degrees. We will subtract from this equality 65 degrees, and we will get that y equals to 65 degrees. So we found out that angle y equals to 65 degrees. Okay, so this angle equals to 65 degrees. So we focus on the green triangle, the right green triangle, triangle SMR. And the right blue triangle, triangle SNR. So actually, on those two triangles, we have a common side. SR is a common side. It belongs both to the blue triangle, and SR belongs also to the green triangle. So SR equals to SR as a common side. SR equals to SR as a common side. SR equals to SR as a common side, and this is a right angle, and this is also a right angle, so those two angles are equal to each other. They are both equal to 90 degrees, so angle SMR is equal to angle SNR, and both those two angles are right angles. They are equal to 90 degrees. Okay, so angle SMR equals to angle SNR, and they are both equal to 90 degrees. And those two angles are also equal to each other. They are both equal to 65 degrees. So we can write that angle MRS equals to angle NRS, and both those two angles are equal to 65 degrees. So angle MRS equals to angle NRS, and they are both equal to 65 degrees. We know that the sum of the angles in any triangle equals to 180 degrees. So if we focus on the green triangle or on the blue triangle, it is the same. It is the same because they are both as two angles that are equal to each other. So here 65 degrees plus 90 degrees, 65 degrees plus 90 degrees plus the size of this angle, let's define it as angle Z. So the sum of those three angles in the green triangle the sum of this angle on the green triangle must be equal to 180 degrees, and actually Z is also the size of this angle because we have two angles that are equal to each other. So the third angle must be equal also in both triangles. So actually we have 65 degrees plus 90 degrees is 155 degrees. and 100 degrees minus 155 degrees is 25 degrees, so we got that angle Z equals to 25 degrees. So actually angle Z equals to 25 degrees. It means that this angle is 25 degrees and this angle is also 25 degrees because they have exactly the same angles. So we can write down that angle MSR equals to angle RSN or angle NSR, and both those two angles are equal to 25 degrees. Okay, so we actually found out that all the three angles of the green triangle are equal to all the three angles of the blue triangle, and we also have a common side that belongs to both triangles. Therefore, we actually proved that the green triangle, triangle SMR, can congruent to triangle, the blue triangle, triangle SNR. Okay, triangle, the green triangle, triangle SNR, congruent to the blue triangle, triangle SNR, according to angle side angle rule. Angle side angle rule. Okay. Again, the green triangle congruent to the blue triangle according to angle side angle rule. Okay, the green triangle congruent to the blue triangle according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if one triangle has one side and two angles that near this side that are equal to one side and two angles that are near this side, then those two triangles are congruent to each other according to angle side angle rule. Okay? So from the fact that the green triangle congruent to the blue triangle, we can conclude that side SM of the green triangle equals to side SN of the blue triangle. SM equals to SN, SM equals to SN, according to the rule that corresponding sides in congruent triangles are equal to each other. The green triangle congruent to the blue triangle, therefore those two corresponding sides are also equal to each other. That is to say, SM equals to SN. Okay, so in the next step, we will focus on the right triangle, triangle SMP, and on the right triangle, triangle SNQ. Okay, so we will focus on the right triangle, triangle SMP, and on the other right triangle, triangle SNQ. On those two right triangles, we know that PS equals to SQ according to what is given us in the question. PS equals to SQ. Again, PS equals to SQ, it is given us in the question. And we also proved that SM equals to SN, okay? Because of the fact that the green triangle can go into the blue triangle, we proved from that we can conclude that SM equals to SN. SM equals to SN. Okay, SM equals to SN, and PM equals to NQ. PM equals to NQ. Actually, we will prove that PM equals to NQ because of the fact that those two triangles are right triangles. We can use the Pythagoras theorem in order to calculate the value of PM. The value of PM, according to the Pythagoras theorem, PM equals to PS squared to the root of PS squared minus SM squared. Okay, again, the value of PM according to the Pythagoras theorem, because of the fact that SMB is a right triangle, we can use the Pythagoras theorem in the right triangle SMP. So PM will be equal to the root of PS squared minus SM squared according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the value of NQ according to the Pythagoras theorem, NQ will be equal to the root of SQ squared minus SN squared. Again, Qn equals to the root of SQ squared minus SN squared according to the Pythagoras theorem. Okay? But we know that PS equals to SQ. PS equals to SQ, and SM equals to NS. You can see here, SM equals to SN. SM equals to SN. Therefore, actually, those two expressions are equal to each other. That is to say, PM equals to Qn. Okay? So, we proved that PM equals to Qn according to the Pythagoras theorem. PM equals to Qn. Okay? PM equals to Qn. So we actually proved that the three sides of the right triangle SMP are correspondingly equal to the three sides of the right triangle SNQ. Therefore, we actually proved that the right triangle SMP can go into the right triangle SNQ according to side rule. Okay, so I write it down. So actually, the right triangle SMP, this right triangle, is congruent to the right triangle SNQ, this triangle, according to side rule. repeat again. Triangle, the right triangle, triangle SMP, congruent. This is the sign of congruent. Congruent to the right triangle, triangle SNQ according to side rule. So what is side rule? If you prove that one triangle, the three sides of one triangle are correspondingly equal to three sides of another triangle, then you actually proved that those two triangles can go into each other according to side rule. Okay? So from the fact that those two right triangles congruent to each other, we can conclude that actually those two angles are equal to each other. Okay, so angle SPM, this angle, equals to angle NQS. And to this angle, and if we define this angle as theta, then this angle will be also equal to theta, because they are equal to each other. Okay, so angle SPM equals to angle NQS, and they are both equal to theta. Okay? And we actually have a rule, I will call it rule number 1. According to rule number 1, if line segment subtends to equal angles, then the 4 points lie on a circle. So I'll read again rule number 1. Rule number 1 states that if line segment subtends two equal angles, then the 4 points lie on a circle. Actually, we can implement rule number 1 in our drawing, because here we have two equal angles. Both those two angles are equal to theta, and they are both subtend on the line segment SR. So according to rule number 1, the 4 angles Q, P, S, and R lie on a circle. So we actually will draw this drawing again, and we will draw a circle around this point, around these 4 points, and those four points will lie on the circle that I will draw. That is true according to rule number 1. So if we have a circle, or okay, we will draw a circle so again those 4 points S, R, Q and P lie on a circle. So I actually drew a circle, and according to rule number 1, points S, R, P and Q lie on this circle. Okay, that is the meaning of rule number 1, that if you have two equal angles that subtend on the same line segment, that is to say SR, so you can see this angle subtend on SR, and this angle theta also subtend on SR. Therefore, according to rule number 1, those 4 points, that is to say S, R, P and Q, lie on a circle, lie on this circle that I draw. So that is actually the implementation of rule number 1 in our drawing. Okay, and we also have rule number 2. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So we actually can implement rule number 2 in our drawing here. As you can see from this drawing, we have angle X, the peripheral angle X subtend on chord PQ, this chord. Again, peripheral angle X subtend on chord PQ, and peripheral angle PRQ that equals to 50 degrees also subtend on the same chord PQ. Therefore, those two angles that subtend on the same chord, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. Again, according to rule number 2, peripheral angles that subtend on the same chord are equal to each other. And here in our drawing here we have two peripheral angles that subtend on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees. So we found out the value of angle X. That was the question. We answered on the question and we found out the value of X according to the first method. So we finished with the first method, and in the next step we will find the value of angle X according to the second method. So we can write here that X equals to 50 degrees, as we have already found. And then we will find out the value of X according to the second method. Here we know that SP equals to SQ, SP equals to SQ, angle SRP equals to 65 degrees, and angle PRQ equals to 50 degrees. Again, PS equals to SQ, and we want to find out the value of angle X. Okay, so in the second method we will do another construction. We will actually extend side SR by a straight line, and from point Q we will raise perpendicular to the extended segment line SR. Again, from point Q we will draw a perpendicular to the extended line segment SR. So because of the fact that it is a perpendicular, this angle equals to 90 degrees. We'll define the touching point between the perpendicular to the extended SR as point M. This point equals to point M, is defined as point M, and this angle is a right angle because QM is perpendicular to SR. Then we will extend QM in such a way that here Q dash M will be equal to QM. Again, Q dash M equals to QM according to our construction. Why? Because we extended QM until Q dash M equals to QM. So we can write here that QM equals to Q dash M according to our construction. Then we'll join together points R and Q by a straight line. And we'll join together points S and Q dash. Here we join together points R and Q dash by a straight line. And in the next step we will join together points S and Q dash by a straight line. Okay. So what is the size of this angle? Let's define it as angle Y. We know that Q dash is a straight line because QM is a straight line and we extended QM by a straight line, so Q dash is a straight line. Line segment Q dash is a straight line. Therefore, we know that the sum of the angles on any point, in any point on the straight line must be equal to 180 degrees, and especially at point M, the sum of the angles must be equal to 180 degrees. So if we focus at point M, along the straight line Q dash, we know that the sum of the angles at point M equals to 180 degrees. That is to say, this angle that is 90 degrees plus this angle that is defined as Y must be equal to 180 degrees according to the rule that the sum of the angles on a straight line equals to 180 degrees. So here we will subtract from this equality 90 degrees and we will get that the size of angle Y is 90 degrees. So angle Y is a right angle. So we actually found out that this angle is a right angle. It equals to 90 degrees. Okay. And we also know that Q dash M equals to QM. That is true according to our construction. Q dash M equals to QM. Okay, so in the next step we will focus on those two right triangles. We will focus on the right triangle QMR, and the right triangle triangle Q dash MR. This right triangle. So on those right triangles, we know that QM equals to Q dash M. That is according to our construction. Again, QM equals to Q dash M according to our construction. We built Q dash M in such a way that it will be equal to QM. We also know that those two angles are equal to each other. They are both equal to 90 degrees. So we can write down that angle QMR is equal to Q dash, angle Q dash MR, this angle. And both those two angles are right angles. They are both equal to 90 degrees. Okay, so angle QMR equals to angle Q dash MR, and they are both equal to 90 degrees. And also we have here a common side. RM is the common side. It belongs both to the right triangle, triangle Q dash MR, and side RM also belongs to the right triangle, triangle MRQ. So we can write down that RM equals to RM equals to RM. It is a common side. Okay, so RM equals to RM. It is a common side. It belongs to both triangles. So we actually proved that triangle, the right triangle, triangle QMR is congruent to the right triangle, triangle Q dash MR according to side rule. So I write it down. We found out that triangle, the right triangle, triangle QMR is congruent. This is the sign of congruent to triangle Q dash MR according to side angle side rule. Okay, so those two right triangles, QMR and Q dash MR, can go into each other according to side angle side rule. So what is side angle side rule? If you prove that two sides and the angle between them are correspondingly equal, in one triangle are correspondingly equal to two sides and the angle between them on the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. Okay? So from the fact that the right triangle QMR can go into the right triangle Q dash MR, we can conclude that side QR equals to side Q dash R. Okay? Side QR equals to side Q dash R. QR equals to Q dash R according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be also equal to each other. And actually, after we extended SR by itself is a straight line, and we extended SR by a straight line, so SRM is a straight line. Therefore, the sum of the angles at any point on the straight line SM equals to 180 degrees. Therefore, 65 degrees plus 50 degrees, 65 degrees, if we look at point R, 65 degrees plus 50 degrees plus the size of this angle that we will define it as Z must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line equals to 180 degrees. Okay, so 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line equals to 180 degrees. So here if we subtract 50 degrees from this equality, we will get that 65 degrees plus Z equals to 130 degrees. And if we subtract 65 degrees from this equality, we will get that Z equals to 130 degrees minus 65 degrees equals to 65 degrees. So we actually found out that angle Z equals to 65 degrees. So we can write here that angle Z equals to 65 degrees. And we've already proved that this right triangle MQR is congruent to triangle QDSMR. Therefore, those two angles are equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle is 65 degrees, this angle must be also equal to 65 degrees. Okay? And we also concluded from the fact that those two triangles congruent to each other that actually QR equals to QDSR. So so QR equals to QDSR, and we know that SP equals to SQ, so if we define SP as Y, then SQ will be also equal to Y. Okay, so in the next step we will focus on the right periodic triangle SMQ, and on the big right triangle SMQDES. Okay, so on those big right triangles, we know that QM equals to QDSM according to our construction. QM equals to QDSM according to our construction. Again, QM equals to QDSM according to our construction. And we know that those two angles are equal to each other, they are both equal to 90 degrees. So angle QMS, this angle, is equal to angle QDSMS, and they are both equal to 90 degrees. Again, angle QMS equals to angle QDSMS, and they are both equal to 90 degrees. And we have a common side, SM equals to SM. It is a common side, it belongs to both triangles. So SM equals to SM. It is a common side. Again, SM equals to SM, it is a common side. So we actually proved that the right big triangle SMQ is congruent to the right big triangle SMQ dash according to angle side angle rule. So I'll write it down. We found out that triangle, the right big triangle SMQ is congruent to the right big triangle SMQ dash according to side angle side rule. So what is actually side angle side rule? If you prove that one triangle has two sides and the angle between them that correspondingly equal to two sides and the angle between them of the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. So from the fact that the two big right triangles can go into each other, we can conclude that SQ equals to SQ dash. Okay, so, and SQ equals to SQ dash according to the rule that corresponding sides in congruent triangles are equal to each other. So if SQ equals to Y, then SQ dash will be also equal to Y. Okay? Again, those two sides are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be also equal to each other. Okay? So, in the next step, we will focus on triangle SRQ and triangle SRQ dash. And we actually will prove that those two triangles can go into each other. Again, we will focus on triangle SRQ and triangle SRQ dash. Okay. First of all, we have already proved that SQ equals to SQ dash equals to Y. SQ equals to SQ dash equals to Y. Okay. And we also have already proved that RQ equals to RQ dash. RQ equals to RQ dash. RQ equals to RQ dash. And we have a common side. SR belongs to both triangles, to triangle SRQ dash, and SR also belongs to triangle SRQ. So SR equals to SR is a common side. SR equals to SR, it is a common side. It belongs to both triangles. So we actually proved that triangle SRQ is congruent to the triangle SRQ dash according to side rule. So I'll write it down. So triangle SRQ is congruent to triangle SRQ dash according to side rule. So what is actually side rule? Side rule states that if you prove that three sides of one triangle are correspondingly equal to three sides of another triangle, then those two triangles can go into each other according to side rule. So from the fact that triangle SRQ congruent to triangle SRQ dash, those two triangles congruent to each other, we can conclude that those two angles are equal to each other. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so I write it down. So angle SQR is equal to angle SQ dash according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding angles will be equal to each other. And if we define, so angle SQR equals to angle SQ dash R, and if we define angle SQR as theta, then angle SQ dash R will be also equal to theta because those two angles are equal to each other. Okay, so angle SQR equals to angle SQ dash R, and they are both equal to theta according to our definition. Okay, so in the next step we will prove that PRQ dash is a straight line, and we prove it by proving that at point R we have 180 degrees. On this side of line PQ dash we have 180 degrees, and according to the rule that the sum of the angles on a straight line equals to 180 degrees, PQ dash will be equal to a straight line, will be a straight line. So at point R on this side of line PQ dash, we have 50 degrees. At point R we have 50 degrees plus 65 degrees plus 65 degrees. Okay, so those are the angles that we have at point R. So 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees equals to 180 degrees. So we actually proved that at point R we have 180 degrees on this side of line PQ dash. Therefore, PQ dash is a straight line. According to the rule that the sum of the angles on a straight line equals to 180 degrees, so PQ dash is a straight line. Again, PQ dash is a straight line because of the fact that at point R on this side of line PQ dash we have in total 180 degrees. Therefore PQ dash is a straight line. From the fact that PQ dash is a straight line, we can conclude that SPQ dash is a triangle. Okay, we can conclude that SPQ dash, this structure, is a triangle. So SPQ dash is a triangle. So in triangle SPQ dash we have two sides that are equal to each other. That is to say, SP equals to SQ dash, SP equals to SQ dash. Again, in triangle SPQ dash, we know that SP equals to SQ dash, and according to the rule that in front of equal sides in a triangle we have equal angles, there are equal angles. Those two angles that are located in front of those two equal sides must be also equal to each other. So if this angle is theta, then this angle must be equal also to theta. Again, according to the rule that in front of equal sides in the triangle there are equal angles, those two angles that are located between in front of those two sides that are equal to each other, they must also equal to each other. Therefore, if this angle is theta, this angle must be also equal to theta. Okay? So from this point, we will continue exactly to according the first method. In the first method, we used rule number 1. In rule number 1, actually, it states that if two equal angles subtend on a segment line, on the same segment line, then the 4 points Q, P, S, R lie on a circle. So therefore, according to rule number 1, because of the fact that we have two equal angles that are both equal to theta that subtend on the same segment line SR. Therefore, according to rule number 1, points SR, Q, and P lie on a straight line, lie on a circle. Points SR, Q, and P lie on a circle, according to rule number 1. Okay, so we'll draw a circle with points S, R, Q, and P on the circle. Again, according to rule number 1, because of the fact that those two angles that are equal to each other, they are both equal to theta, subtend on the same segment line, that is to say they are both subtend on SR. Therefore, according to rule number 1, points S, R, P, and Q lie on a circle. Okay, as you can see, points S, R, Q, and P lie on this circle, on the blue circle. That is the implementation of rule number 1 in our drawing. In our drawing, again, we have two equal angles that subtend on the same segment line SR. Therefore, points S, R, Q, and P lie on a circle. As you can see, points S, R, S, P, S, R, and Q lie on the blue circle. And we have also rule number 2 that states that peripheral angles that subtend on the same chord are equal to each other. Here we have peripheral angle X that subtend on chord PQ, and we have peripheral angle PRQ that equals to 50 degrees that also subtend on the same chord PQ. Therefore, according to rule number 2, those two angles that subtend on the same chord are equal to each other. That is to say, X equals to 50 degrees. X equals to 50 degrees according to rule number 2. According to rule number 2. So we actually proved that angle X equals to 50 degrees according to the second method. So in the next step, I will summarize the lecture. So we actually wanted to find out the value of angle X the value of this angle X. We know that angle SRP equals to 50 degrees, angle PRQ equals to 50 degrees, angle SRP equals to 65 degrees, and we want to find out the value of angle PSQ that defined as X. So in order to find out the value of angle X, we extended QR until point M. Actually, from point S, we draw perpendicular to the extended QR, and actually here we have 90 degrees because of the fact that SN is perpendicular to extended QR, and from point S we also drew perpendicular to PR. At point M, SM actually creates 90 degrees at point M with PR. So this angle is 90 degrees and this angle is also 90 degrees. Then actually QR is a straight line and we extended the straight line by straight line, so QN is also a straight line, and we know that the sum of the angles on a straight line equals to 180 degrees. Therefore, if we focus on this straight line QN at point R, we know that the sum of the angles at point R must be equal to 180 degrees. Therefore, if 50 degrees plus 65 degrees plus the size of this angle must be equal to 180 degrees. We define this angle as angle Y. So 50 degrees plus 65 degrees plus angle Y equals to 180 degrees. So here we subtracted 50 degrees from this equality. We got that 65 degrees plus Y equals to 130 degrees. We subtracted 65 degrees from this equality and we got that angle Y equals to 65 degrees. So we found out that this angle equals to 65 degrees. Then we actually proved that the green triangle can go into the right triangle. Actually, we have a common side, SR. It belongs to both the green triangle and the blue triangle. So SR equals to SR is a common side. SR equals to SR is a common side. And then we know that those two angles are equal to each other. They are both equal to 90 degrees. And those two angles are also equal to each other. They are both equal to 65 degrees. And we also know that the sum of the angles in any triangle equals to 180 degrees. The sum of the angles in the green triangle equals to 180 degrees. So we have two angles that equals to 90 degrees plus 65 degrees. So in order to complete the sum of the angles in the green triangle to 180 degrees, this angle must be equal to 25 degrees, and the same thing is true in the green triangle. So those two angles are both equal to 25 degrees. Okay, so we actually proved that all the angles in the green triangle are equal to all the angles in the blue triangle. And we also have a common side that belongs to both triangles, so SR equals to SR. And the therefore, actually, the green triangle can go into the blue triangle according to angle side angle rule. Again, the green triangle can go into the blue triangle according to angle side angle rule. So what is angle side angle rule? If you prove that two sides and the angle between them in one triangle correspondingly are equal to two sides and the angle between them on the other triangle, then you actually proved that those two triangles can go into each other according to angle side angle rule. From the fact that the blue triangle can go into the green triangle, we can conclude that SM equals to SN, those two sides, SM equals to SN, those two sides are equal to each other, according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, so in the next step, we focused on the right triangles, this right triangle, triangle SMP, and this right triangle, triangle SNQ, and we proved that those two right triangles are also congruent to each other. First of all, we know that PS equals to SQ. It is given us in the question that those two sides are equal to each other. PS equals to SQ. Then we have already proved that SM equals to SN. Okay, SM equals to SN according to what we have already proved. And PM equals to NQ. Why PM equals to NQ? Because we have here two right triangles. And according to the Pythagoras theorem, that the sum of the perpendicular, the square of the perpendicular equals to the sum of the squares of the sum of the hypotenuse equals to the sum of the squares of the perpendiculars. PM, this right triangle equals to the root of SP square minus SM square. Again, PM in the right triangle, SMP equals to the root of PS square minus SM square. And what is the value of NQ in the right triangle SNQ? NQ will be equal to the root of SQ square minus SN square. Okay? NQ equals to the root of SQ square minus NS square or SN square. But we know that PS equals to QS. Okay, it is given us the question, and we also proved that SM equals to SN. So those two expressions identical, they are equal to each other, therefore PM equals to NQ. So we actually proved that PM equals to NQ. So we actually proved that the right triangle SMP can go into the right triangle SNQ according to side rule. Okay, what is side rule? If you prove that three sides of one triangle are correspondingly equal to three sides of another triangle, then you actually prove that those two triangles can go into each other according to side rule. From the fact that those two right triangles can go into each other, we can conclude that angle SPM equals to angle NQS. Angle SPM equals to angle NQS according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle is theta, this angle will be also theta because of the fact that those two angles equal to each other. Okay, and then we have rule number 1 that states that if line segment subtends two equal angles, then the 4 points lie on a circle. So here we have two equal angles, they are both equal to theta, that subtend on the same segment line SR, and according to rule number 1, those four points P, Q, S, and R lie on a circle. Okay, so according to rule number 1, points S, R, P and Q lie on a circle. Why? Because of the fact that those two equal angles lie on the same segment line. Therefore, points S, R, P and Q lie on a circle. Lie on this circle, and then we have rule number 2 that states that peripheral angles that subtend on the same chord are equal to each other. Here we have peripheral angle X that subtend on chord PQ, and we have peripheral angle PRQ that equals to 50 degrees that also subtend on the same chord PQ. Therefore, according to rule number 2, those two angles are equal to each other. That is to say, angle X equals to 50 degrees. So we found out that angle X equals to 50 degrees. That was the first method. And we actually also, so we finished with the first method, and according to the second method, in the second method actually we did another construction. We actually extended SR by a straight line, and then from point Q we drew perpendicular to extended SR, so this angle is 90 degrees, and then we extended QM in such a way that Q dash M will be equal to QM. Okay, Q dash M equals to QM according to our construction. So what is the size of this angle? Then actually after we extended SR, here we know that SM is a straight line. Therefore, the sum of the angles on the straight line at any point equals to 180 degrees. Therefore, 65 degrees plus 50 degrees plus the size of this angle equals to 180 degrees. So here we have 65 degrees plus 50 degrees is 150 degrees, 115 degrees. So this angle must be equal to 65 degrees in order to complete the sum of the angles at point R to 180 degrees. Okay, then we calculated the size of this angle. We know that Q dash is a straight line, and the sum of the angles on the straight line must be equal to 180 degrees. So this angle that equals to 90 degrees plus this angle that is defined as angle Y must be equal to 180 degrees. We subtracted 90 degrees from this equality, and we got that angle Y equals to 90 degrees. So this is a right angle. Okay. So actually here, after we extended QM in such a way that Q dash M equals to QM, then we join together points R and Q dash by a straight line, and then we join together points S and Q dash by a straight line. Okay, then we focused on the right triangles SMR and triangle Q dash MR. On those two right triangles, we know that QM equals to Q dash M according to our construction. We also know that those two angles are right angles and they are equal to each other. And we have a common side, RM equals to RM. It belongs to both triangles. So we actually proved that the right triangle QMR is congruent to the right triangle Q dash MR according to side angle side rule. Okay, so from the fact that those two triangles can go into each other, we can conclude that QR equals to Q dash R, according to the rule that corresponding sides in congruent triangles are equal to each other. Therefore, QR equals to Q dash R. Okay? And then we focused on the right brick triangle QMS, and the right brick triangle Q dash MS, and we proved that those two right triangles can go into each other. First of all, we know that QM equals to Q dash M according to our construction. We also know that those two angles are right angles and they are equal to each other, therefore, because they are both equal to 90 degrees. And we have a common side, SM equals to SM, because it belongs to both triangles. So we actually proved that the right triangle SMQ is congruent to the right triangle SMQ dash according to side angle side rule. So what is side angle side rule? If we prove that two sides and the angle between them in one triangle are correspondingly equal to two sides and the angle between them on the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that SQ equals to SQ dash, according to the rule that corresponding sides in congruent triangles are equal to each other. Because of the fact that those two triangles can go into each other, those two corresponding sides SQ and SQ dash will be equal to each other. Okay, so if this side is y, then this side will be also equal to y, because they are equal to each other. But we also know that those two sides are also equal to each other according to what is given us in the question. So if this is y, then this is also will be equal to y, or PS will be also equal to y. Okay, then we focused on triangle SQR and on triangle SRQ dash. On those two triangles, we actually proved that those two triangles can go into each other. First of all, we know that SQ equals to SQ dash. SQ equals to SQ dash, we've already proved it. We also know that RQ equals to RQ dash, we proved it. And SR is a common side, it belongs to both triangles, so SR equals to SR is a common side. So we actually proved that those two triangles can go into each other according to side rule. So what is side rule? If we prove that three sides of one triangle correspondingly are equal to three sides of another triangle, then you actually proved that those two triangles can go into each other according to side rule. Okay? So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle is theta, this angle will be also equal to theta because of the fact that those two angles are equal to each other. Okay, so angle SQR equals to angle SQ dash R equals to theta. Okay, then we proved that line segment PQ dash is a straight line. How we proved it? We proved that at point R we have 180 degrees, and we have the rule that the sum of the angles on the straight line equals to 180 degrees. Therefore, actually PQ dash must be equal to 180 degrees because of the fact that at point R we have 180 degrees. Actually, we have here 50 degrees plus 65 degrees plus 65 degrees, and it equals to 180 degrees. Therefore, this angle is an angle that equals to 180 degrees, and angle that equals to 180 degrees is a straight line. Okay, angle that equals to 180 degrees, it is a straight line, therefore this is a straight line because of the fact that this angle equals to 180 degrees. That is to say, PQ dash is a straight line. So from the fact that PQ dash is a straight line, we can conclude that structure PSQ dash is a triangle. So in triangle PQ dash S, we have two sides that are equal to each other. Those two sides are both equal to y. And we have a rule that states that in front of equal sides in the triangle, there are equal angles. So in front of these two sides, we have two equal angles. That is to say, those two angles are equal to each other because they are located in front of equal sides, y and y. So this angle equals to theta. Therefore, this angle must be also equal to theta because of the fact that those two angles are equal to each other. So if this angle is theta, then this angle must be also equal to theta. Then we continued according to the first method. We use rule number 1 that states that if you have two angles that subtend on the same segment line SR, then the 4 points P, Q, S and R lie on a circle. We have two angles that are equal to each other, they are both equal to theta, therefore, and they lie on the same segment line SR, therefore we can put points P, Q, R and S on a circle. So here we put points S, R, P, Q on a circle because of the fact that those two angles that are equal to each other lie on the same segment line SR. Therefore, we can put points P, S, R and Q on a circle. So actually we have here two peripheral angles that subtend on the same chord PQ. Angle X subtend on chord PQ, and angle PRQ that equals to 50 degrees subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, angle X equals to 50 degrees. So, according to rule number 2, angle X equals to 60 degrees. So, we found out, according to the second method, that the size of angle X is 50 degrees. Or angle PSQ that equals to X equals to 50 degrees. Okay? Thank you very much.